of experimentation. Because experimentation, by definition, means most experiments will fail to find the one that succeeds. And that cost has to come down. And the risk tolerance needs to go up. And in most large enterprises, traditional enterprises, the risk tolerance is very, very low for doing something new. And if something fails, it can be a career-ending move for people. Because the idea of experimenting to discover what works is not in the culture of most large traditional applications. But the goal of us building the model was to figure out what to focus on. When you're trying to scale on in an organization, go from one or two small teams which are doing innovation, but to bring that innovation culture through an entire organization, what do I focus on standardizing and what do I not focus on standardizing? And when we talk about an area to standardize, we mean both technology and we also mean the processes. So language you're going to develop your code in is not on this list because you want to let the developers develop code in whatever language they want. Technology stacks are not in this list, but aspects of technology are in this list. So we'll delve into each and every one of these. So planning. What I'm going to do is for each and every one of these, I'm going to talk about, as I go through these slides, the aspect which is relevant to us as InfoSec professionals. Getting involved, oh, you like that, you like my, oh, by the way, I spend more time finding the memes than on writing the slide. As you can see, the slide is 6 words. Yeah, who needs a plan, right? Getting involved in early planning stages as the InfoSec owners is absolutely critical. You all know this, we all know this, right? But it is absolutely critical, and we as InfoSec professionals have to push back on people who are doing agile and say, you have to include us. You can't exclude us. You cannot do your planning without keeping security in mind. You cannot staple on security after the fact. At the end of the day, your system will be as secure as the least secure component, as a lot of organizations have recently found out in some of these very public breaches. In order to understand that, one needs to very quickly understand very well the architecture of those applications and understand what the dependencies of those architectures are. And as I said earlier, we are excellent at adding technology stacks, horrible at removing them. Who will drive under this building, man? If they move the refrigerator from the left to the right, I mean, this party is over. But you'd be surprised how many actually, and I do a lot of application architecture assessments, how many applications I could give them this picture and say, this is what your application's architecture looks like. Yep, very, very. Unfortunately, both these pictures are from India, this one and this one. Could be any third world country, right? Yeah. But I know what language that is, so yeah, it's from India. After architecture comes deployment automation. How is that being automated and self-service being provided by security professionals so that the vulnerabilities are detected before the code is deployed, even if it is deployed to a test environment, right? There was a large hotel chain which was breached recently. I'm not giving any names, but you can Google it. And it was breached via a test environment where code which had a vulnerability had been deployed, and their goal was to deploy it to a test environment and then do the vulnerability testing. Too late. Too late, right? You have to do the vulnerability testing beforehand. So security practitioners need to shift from being enforcers to enablers by delivering automation as a part of the delivery automation stack. I'm meeting with a CIO of a bank, right? And he's had me come in and I deliver a keynote, and we are meeting later for lunch. And I'd shown this slide, and this guy's from New Zealand, right? And in his fake, Gerard Butler accent, he's trying to say, tonight we test in prod. Sanjeev, that was the most hilarious slide, ha, 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 ha. And the whole table is quiet, right? And I'm like, what happened here, man? And people look up, and his VP of App Dev looks up to him and says, Joe, the last deployment, the release we made last year, 2 months ago, we tested in prod. We ran out of time. But this is the reality, right? And here's the key, right? If you're doing 2-week sprints, but it takes 3 weeks to get security to approve something, how long are your sprints? It has to be a part and parcel and in sync with the whole process of delivering code. This is, by the way, this slide, if you ever go to a DevOps presentation, we are legally required to put this slide in. Yes, sir? Sure. Absolutely, and it's a cultural thing. I mean, the worst example of that, which we all saw very publicly, was healthcare.gov, right? It wasn't a security problem, but of the few 100,000 people who were supposed to sign up on day one, how many knows how many signed up? 6. Because the login page didn't work. It was integration testing was skipped to make the deadline. It is citing examples like that that we can teach our other leadership who are responsible for creating these unrealistic schedules and say, you have to give somewhere, right? True. What would you rather have? A healthcare.gov which was delayed or healthcare.gov which was released the way it was released? And the cost of fixing it was humongous. And it wasn't that the individual pieces didn't work. The individual pieces worked. They skipped integration testing. And prod became test, and the test failed. And out of 200,000 people who were expected to register, only 6 got past the login page. That's a pretty bad failure, right? So what I typically do is work with executives and cite examples like that to let them know that this is what will happen if we skip a stage. Right? We have to get all the stages through because we end up otherwise testing in prod, and that's not a happy situation. Absolutely. Through every stage. Yes. It should be a part and parcel. Sure. And back in the day, and this is still valid, right? I mean, there was a study done about how the cost of fixing something goes up based on which stage of your application delivery lifecycle. And I know that study is not as valid as much because if you're doing true DevOps and continuous delivery, you don't have those stages. But the idea was that if you found a defect during requirement stage and it cost you $1, it'll cost you $10 when fixed in coding, it'll cost you $100 when fixed in test, and $1,000 when fixed in integration test, and $10,000 when fixed in prod. That ratio still remains. Right? It is 10,000 times more expensive, and think of the reputational impact of finding something wrong or something that could be found. Right? If you don't know, something cannot be found, that's different. But something, a known defect, a known vulnerability, finding it in prod, it is, and the point is that technology exists today to be able to catch it much sooner. That's why all that automation, spot on, is very critical. This is a quote from a defense contractor I did a project with, and he was telling me, these cruise missiles, they don't have a Cat5 port on the side. There is no OTA. It's not like Tesla where you can over-the-air update the patch, right? In fact, he was giving me an example that, how they update software on a Navy ship? The ship has to dock. New servers will be sent there. The old server will be removed, and the new server will be put in. There is no way to patch software while it has been deployed on a ship. You have to remove the entire server. So think about the cost of doing that if there is a minor defect which could have been caught and fixed before it was deployed. Same way with a missile, right? Once it's launched, it's launched, right? It's going to hit a target or hit something else, right? That's why they have abort buttons on them. But if the defect is in the abort button command, what do you do then? And last but not the least is operational readiness, right? And there's this whole concept, and I think you guys were talking about it, at least those of you who were in the morning session, I think you all were talking about moving from mean time between failure to mean time to repair, but what you repair is more critical, right? And as we move towards, I'll give you a second to read this tweet. As we move towards a containerized microservices world, it is becoming more and more complex. right? Because you're not talking about fixing one defect where there's one application with one service. It is an amalgamation of services which are getting composed on demand in real time, and you have to do your root cause analysis on that to figure out where the defect was. Eventually, it's all about culture, as we've been discussing, right? Everybody needs to be responsible. This is the best T-shirt, actually, I ever saw. And this T-shirt was at an insurance company. Their app dev leader was giving it out to everybody. He said, everybody is responsible for delivering value to the customer. He gave it to all his development team, his QA team, his ops team. Then he went and gave it to the janitor and said, hey, listen, if the restroom is closed during work hours for some cleaning you are doing, and people have to go to another floor, waste 10 minutes, you just delayed deploying customer value. He went and gave it to the CFO and said, hey, if you furlough my developers around in December, you have now suddenly delayed delivering business value to the customer. He went and gave it to the coffee machine and vending machine repair guy and said, people have to go to Starbucks because they can't get their coffee. That's the cultural aspect of it. Everybody is a stakeholder and an equal stakeholder. There can't be somebody special. Which goes back to my point, why I don't like the term DevSecOps. Why call it out? If you say DevOps, it includes security. By the very definition of DevOps, it includes everybody. So the new aspect, so let's talk about what's coming, right? Where is this all headed, right? And the new area which has been emerging in the area of readiness, in the area of resilience and response, incident response, is the whole concept of chaos engineering. Chaos engineering is not a new term, it's been around forever, but the people who were first to productize it and codify it in the IT space was Netflix. Netflix created something called the Simian Army. Their first product was called Chaos Monkey. And the thinking was very simple. If you have a blowout of a tire on a cold wintry day on a dark highway, can you replace the tire? Now, if you ask me, I'll say, yeah, I have AAA on speed dial on my phone. But what if cell service is out? Can you replace the tire? How do you know you are sure you can replace the tire? Well, the only way to do it is every Sunday afternoon, you pull the car into the driveway, you take a screwdriver, make a hole in your tire, have your kids stand around you throwing cold ice water on you while you change the tire. If you do that enough times, you'll be good at changing a tire and you'll be confident that the tire can be changed should you ever need to do it under these bad circumstances. And we do it all the time. How many of you have ever participated in a fire drill? That is essentially at the least expected time. That's where it really should be, but instead we all get an email saying there'll be a fire drill today at 1 a.m. What the heck? That's when I go for a break because I don't want to be a part of the fire drill and stand outside. But that is the thinking behind chaos engineering. The way Netflix has delivered it is they delivered a suite of tools and they open source them, which randomly go skill services in actual production. And the whole goal is to get their engineers in a mindset that they will deliver code which can effectively recover, do self-remediation, and all the services which are connected to it can elegantly degrade their performance without dying. So what is the result? Today, if you're watching Netflix, I was just watching Narcos Mexico 2, and they're on the bridge and he's about to shoot Lupita and my stream died, right? And I'm going, dang it, I'm going to miss it, right? I'm still cable mind thinking. But what happened? It got restored immediately. Not only did it get restored pretty quickly, they probably found another node from which they could deliver it to me. The stream got rewound 5 seconds. So I did not miss the experience of him shooting her and seeing the blood splatter all over the back. Have you seen Narcos? If you can't handle that, don't. See, I'm saying this after you've all eaten, right? I didn't say it beforehand. That's the result of true chaos engineering, getting that resilience and reliability into your system and its ability to recover quickly. The thinking is very simple, that we live in a chaotic world where services are going to die all the time because they run exclusively on a cloud and they use third-party services and they're highly, highly distributed. That's the thinking behind it. And today this has been commercialized. There's a company called Gremlin which took all these tools and has developed them a commercial variants of it, like it always happens in this open source world. And in fact, some of them were here yesterday. The thinking behind is you want to develop systems that are anti-fragile. The term anti-fragile came from Nassim Nicholas Taleb. He wrote a book called The Black Swan, not the one about the ballet dancers, This is about the stock market crash, the black swan events. And then he wrote a book called Anti-Fragile. I guess he figured people were asking enough questions, so let me make another million. And the idea of anti-fragile is that there are three kinds of systems in this world. There are robust systems. So if I drop this remote, forgot what it's called, it's robust. It's not going to break, likely. If I drop my iPhone, $600 phone is the fragilest, most fragile piece of electronics ever made. It's going to break if I don't have it in a case. And the third kind of systems are which, when they interact with chaos, they actually become stronger. Most biological systems are like that. If a bone breaks, when it heals, at that spot, the bone is stronger. If you start doing deadlifts, which Exhibit A, I should do, the bones increase their calcium density automatically because when faced with stress, the human body is anti-fragile. It starts getting stronger. Anti-fragile systems are the same way, and they need to thrive in chaos. And I don't need to show you slides like this. We are all InfoSec professionals. This was a Sophos study last year where they put up honeypots, unprotected virtual machines in the cloud all over the world, and wanted to see how quickly do they get hacked. In Sao Paulo, Brazil, it got hacked in 52 seconds. For whatever reason, in Ireland, it took 1 hour, 45 minutes. Wi-Fi is slow in the pubs, I guess. I don't know. But you see the point, right? No matter where you put, there is people hacking. I remember when we were rolling out the container service at IBM, this was during the peak of the Bitcoin price when it was surging. Every time we would deploy a new cluster, somebody would install a crypto miner on it. I'm like, come on, man. We had to write bots which would go and kill Bitcoin miners. In this chaotic world, one needs security chaos engineering. That is, chaos engineering methodologies which are geared towards detecting, identifying, and remediating failures due to security and security incidents all the time. Essentially, democratizing security early, but creating systems which can find the incidents as soon as they happen. More importantly, create examples of those incidents for developers so that they build systems which are ready for those hacking events and those breaches and those attempts to find vulnerabilities to happen, because those vulnerabilities, if they are there in the code, will be exploited. There are 6 aspects of it, right? And most of if you're looking for automation, guidance on automation, like we discussed earlier on, right? This is essentially what we are talking about, right? End-to-end continuous instrumentation, the ability to have observability into security vulnerabilities and which ones of them are attempts being made on to exploit. Continuous readiness assessment, just that's like a fire drill. That's like, poking a hole in your tire and trying to fix it in the dark while your kids are throwing cold water on you. Continuous security gap analysis, looking for new security gaps as they appear, as your code changes and evolves, because that's what it's going to do in an agile DevOps world. It's going to change over time, continuously creating new security gaps in whatever it is you are delivering. And of course, automation on every aspect of security, so that the vulnerabilities and security incidents are identified, detected, and remediated automatically. And we've spoken about this earlier several times, whereas focus on vulnerability and failure identification earlier in the life cycle, right at the developer level, right when the developer writes code, right when the developer builds their code or builds a Docker image out of it. And of course, continuous improvement of operational readiness, right? How can you improve that mean time to recovery next time from whatever you're able to achieve it this time? And do that in a secure, controlled manner by having those vulnerability drills, by doing chaos engineering-like approaches in order to address them continuously.
Elsa, you're all over the place.
How am I supposed to do anything when she's over here just doing her own thing?
Okay, well, maybe if Dan played more than just one string, we'd all be more on the same page.
Are you out of your mind? Okay, I do the E string. That's my job.
Isn't there an easier way to do this?
I
There
wish.
has to be.
I literally just suggested something.
Right?
Nobody ever listens to me, though,
It's
so...
ridiculous every time.
When your team's not on the same page, things can get weird, fast. Don't make your DevOps team live like this.
Il tutto tu tempo is finito, Dan!
See? It's like we're not speaking the same language. I'm out.
GitLab is the only single application for the entire DevOps lifecycle, making sure your teams are all on the same page.
Do you know how to play the E string?
I can learn.
Well, it's certainly been an action-packed, jam-packed Friday show here at TechStrong TV. I'm glad to say we finished the week strong, TechStrong. So I'm not going to, hopefully we'll see you all here on Monday, ready to watch and grab some great news, as well as, keep you busy while you're working. We hope you have a great weekend. Enjoy some sunshine, some fresh air. Stay well, stay healthy, stay strong, stay TechStrong. Have a great weekend, everyone.